Hello and welcome to today's Senior Secondary 2 Physics lesson. Today, we'll be diving into the fascinating world of simple harmonic motion. Before we continue, let's take a moment to briefly revisit our previous lesson. In our last lesson, we explored the differences between speed and velocity. We also identified and interpreted velocity time graphs. We even went ahead to explore instantaneous velocity and acceleration. It was very interesting. Before we dive in, let's look at our lesson objectives. By the end of the lesson, we will be able to define simple harmonic motion, explore the relationship between speed and acceleration in simple harmonic motion, understand the concept of period, frequency, and amplitude of simple harmonic motion. Are you ready? Let's proceed. Simple harmonic motion is a type of repetitive back and forth motion where an object moves around a central point. The force that pulls the object back towards the center is directly related to how far the object is from the center. And this motion continues in a regular repeating pattern. Simple harmonic motion simply refers to a specific type of motion where an object moves back and forth in a regular repeating way. For example, a swinging pendulum. Imagine a swing hanging from a tree. When you push the swing, it moves away from the center and then comes back. Here's how it works in simple harmonic motion. Simple harmonic motion is made up of three key components. 1. Displacement. This is how far the object moves from its center or equilibrium position. In the case of a pendulum, it's how far the swing moves away from the middle. 2. Restoring force. This is the force that pulls the object back towards the center. For the pendulum, gravity is the restoring force that pulls the swing back. 3. Back and forth motion. The object moves away from the center, slows down, and then moves back toward the center, repeating this cycle continuously. This creates the regular repetitive motion we see in simple harmonic motion. So, simple harmonic motion is all about the displacement from the center, the restoring force pulling the object back, and the smooth, repetitive motion that occurs because of it. Next, let's see speed and acceleration of simple harmonic motion. In simple harmonic motion, the speed and acceleration of the object changes over time. Here's a breakdown. 1. Speed in simple harmonic motion. The speed of the object is constantly changing as it moves back and forth. At the center, equilibrium position. The speed is at its maximum, because the object is moving the fastest as it passes through the middle. As the object moves away from the equilibrium position, its speed decreases. The restoring force is zero here, so the object isn't being pulled or pushed, allowing it to move quickly. At the maximum displacement, amplitude. The speed is zero because the object momentarily comes to rest. This is because the object changes direction, so it pauses for a brief moment. Now, acceleration in simple harmonic motion. At the center, equilibrium position. The acceleration is zero because the restoring force is zero. The object is not being pulled or pushed here. At the maximum displacement, amplitude. The acceleration is at its maximum because the restoring force is strongest here. The object is being pulled back toward the center with the greatest force. Next, let's explore period, frequency, and amplitude in simple harmonic motion. In simple harmonic motion, period, frequency, and amplitude are important terms that describe the motion. Let's take a look at them. 1. Period. It is the time taken by the object to complete one full cycle of motion. It is measured in seconds, s. For example, if a pendulum swings from one side to the other and back again in 2 seconds, its period is 2 seconds. 2. Frequency, f. The frequency is the number of complete cycles the object makes in 1 second. It is measured in hertz. Hz. Where 1 hertz equals 1 cycle per second. Frequency can be calculated with the formula F equals 1 divided by T. For example, if the period is 2 seconds, the frequency is 1/2, which equals 0.5 Hz. 3. Amplitude, A. The amplitude is the maximum displacement of the object from its equilibrium position. It shows how far the object moves from the center. It is measured in meters. For example, if a spring stretches 5 centimeters from its equilibrium point, its amplitude is 5 centimeters. In simple terms, period tells how long one full swing takes. Frequency tells how many swings happen in 1 second. And amplitude tells how far the swing moves from the middle. Well done, you are doing great. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Excellent work. You've done a fantastic job following along with today's lesson. Let's take a moment to review what we've covered. Simple harmonic motion simply refers to a specific type of motion, where an object moves back and forth in a regular repeating way. 3 components of simple harmonic motion are displacement, restoring force, and repetition. We also learned that period tells how long one full swing takes. Frequency tells how many swings happen in 1 second. And amplitude tells how far the swing moves from the middle. In our next lesson, we will explore some examples, formulas, and more about simple harmonic motion. Well done. You've come to the end of this lesson. Keep practicing what you've learned. I will see you in the next lesson.